Hi everyone! In this problem, we need to determine the order of growth in time for each of these following functions using big theta notation. So for the first function, Belgian waffle, this function has a while loop that runs n times. Now we know this since I is initially equal to 0, and for every iteration of the while loop, we add I by 1, and this keeps on going until I less than n is false. So this while loop here runs n times. Inside the while loop, there is an inner for loop that runs 50 times n squared times. Now, this for loop runs for each iteration of the outer while loop. Therefore, the total number of iterations in this function is 50n squared times n, which is 50n cubed. Now, since the number of iterations is proportional to n cubed, we can say that the order of growth in time for this function is big theta n cubed. Okay. The next function, pancake n, is a recursive function, as we can see from the return statement that calls pancake n on itself. So here we can see 2 iterations of pancake again. So the base case of this function is when n is 0 or 1. When n is greater than 1, the function calls itself twice with n minus 1 as the argument and adds the result of calling the flip function with n as the argument. Now let's start by considering the base case. So when n is 0 or 1, the function simply returns n, which means that it takes constant time. Now let's consider the case where n is greater than 1. In this case, the function makes two recursive calls with n minus 1 as the argument and calls the flip function. Now we know that the flip function will always perform 3 operations, which means that the flip function takes constant time. So the recursive calls are now the ones that contribute to the overall runtime. So let fn denote the runtime of the pancake function when called with argument n. So this runtime can be calculated by calling the same function on n minus 1 as its argument 2 times, which means fn equals to 2 fn minus 1. Okay, now using this relation here, let's write out the first few terms to really understand what's going on with the code. So if we put in 1 as the argument, we get 1. Same with 0. And if we put in 2, it's 2f1. And if we put in 3, it's 2f2, which is equal to 2f1, which is equal to 4. Okay, and we do the same thing here, where this is equal to, and overall it is equal to 8f1. Okay, now we can see in what we've written down here that there is a pattern that each time n adds by 1, the runtime multiplies by 2. So in general, we can write that f of n is 2 to the n f1. Okay, so from this, we can conclude that the runtime is big theta 2 to the n. Okay, so from our analysis of the pancake function, we know that its time complexity is big theta to the n. Now, the first while loop in the toast function calls pancake n, and this while loop runs n times. Therefore, the time complexity of the first loop in toast is the complexity of pancake n times. So this runs n times the time complexity of pancake, which is 2n. Now, the second loop here runs n times, just n times. So the runtime for the second while loop is n. So we know that all in all, this function has a time complexity of n 2 to the n plus n. However, when calculating orders of growth, we focus on the dominating term. In this case, it is n2 to the n. Thank you.